They bend time, they devour stars, and nothing, not even light, can escape their pull. Today, we dare to explore the most mysterious and terrifying force in the universe, the black hole. Imagine a star much larger than our sun, shining brilliantly for millions of years. But even the brightest stars run out of fuel. When a massive star's core can no longer withstand the immense pressure of gravity, it collapses in on itself. The outer layers explode outward in a supernova, but the core keeps shrinking, becoming denser and denser, until it forms a black hole, a point in space where gravity is so strong that nothing can escape. Not even light. Surrounding this point of infinite density, what scientists call the singularity, is a boundary known as the event horizon. This is the ultimate point of no return. Once anything crosses it, whether a planet, a star, or a single photon of light, it is lost forever to the black hole's grasp. The event horizon is not a solid surface, but an invisible border where the pull of gravity becomes irresistible. Space and time themselves are twisted and stretched to their limits. But not all black holes are created equal. In the vastness of the cosmos, black holes come in different sizes and types. The most common are stellar black holes, which form from the collapse of massive stars. These are only a few times more massive than our sun, but they are incredibly dense. Imagine squeezing a mountain into a space no bigger than a marble. Then, there are intermediate black holes, a mysterious in-between category. These are heavier than stellar black holes, but lighter than the true giants. Scientists have only recently started to find evidence for their existence, and how they form remains one of astronomy's great unsolved puzzles. And finally, there are the monsters, supermassive black holes. These cosmic giants weigh millions, even billions of times more than our sun. They lurk at the heart of nearly every galaxy, including our own Milky Way. At the center of our galaxy, about 26,000 light-years from Earth, lies Sagittarius A, a supermassive black hole 4 million times the mass of our sun. It sits silently, hidden behind clouds of gas and dust, but its gravity shapes the entire galaxy. But what really happens inside a black hole? What would it be like to fall in? The answer is stranger than science fiction. As you approach a black hole, gravity becomes unimaginably strong. If you fell feet first, the pull on your feet would be far greater than the pull on your head. The difference would stretch you out longer and longer until you became a thin, spaghetti-like strand. Scientists actually call this process spaghettification. And then there's time itself. According to Einstein's theory of relativity, the closer you get to a massive object, the slower time moves for you compared to someone far away. Near a black hole, this effect becomes extreme. To a distant observer, you would seem to slow down, almost freeze as you approach the event horizon. For you, time would tick normally, but the universe outside would race ahead. In a sense, a black hole is a one-way ticket to the future. These mind-bending ideas aren't just theory. They're backed up by real data. In 2019, humanity achieved something once thought impossible. We captured the first-ever image of a black hole. Using a network of telescopes spread across the globe, the Event Horizon Telescope, scientists pieced together the shadow of a supermassive black hole in the galaxy M87, 55 million light-years away. The image showed a glowing ring of hot gas swirling around a dark center, the event horizon itself. But that's not all. In recent years, we've detected gravitational waves, tiny ripples in the fabric of space-time, created when two black holes collide and merge. These signals, picked up by detectors like LIGO and Virgo, confirm Einstein's predictions and open a new window on the universe. We are now listening to the echoes of black holes crashing together in distant galaxies, billions of years ago. With every discovery, black holes only become more mysterious. Some scientists wonder if they might be portals to other universes, or shortcuts through space and time, what we call wormholes. Others speculate about white holes, the hypothetical opposite of black holes, which might spit out matter instead of swallowing it. These ideas are still on the frontiers of physics, but they remind us that black holes are not just cosmic destroyers, They could be keys to understanding the deepest mysteries of reality. So what lies beyond a black hole's event horizon? No one knows for sure. Our laws of physics break down at the singularity. Perhaps it's a doorway to another universe. Perhaps it's the end of everything. Or perhaps, as some theories suggest, information and energy are preserved in ways we can't yet imagine. One thing is certain: black holes are not the end. They are a doorway to the unknown, a challenge to our understanding, and a promise that the universe is even stranger and more wondrous than we can imagine. Thank you for exploring the depths of space with us. If this journey into the heart of darkness blew your mind, make sure to subscribe and join us again tomorrow, when we bring things closer to home with the story of Vietnam's journey into space. Until then, keep looking up, because the universe is watching. Like, share, and subscribe to watch next video. Thanks for watching.